Hey everybody, and welcome back to the University of Rhode Island Mathematics Algebra Enhancement Program. In this video we will be talking about ratio, proportion, and percent, and this is part one of a two-part series. Okay, so let's start with ratios. Now the definition is that the ratio of the number a to the number b, provided that b is non-zero, is written as a to b. You can write it like that, or a with a colon b, or a with a division symbol over b. So those are three ways that we can express ratios. Okay, so let's start with a basic example here, and let's write a ratio for each of the following phrases. So for part A, if I know that there are 30 dogs and 25 cats in a kennel, and I were to ask you for the ratio of cats to dogs, we can write it in three different ways. And here I'm going to pause for a second. So we have the following three ratios here, 25 to 30. The 25 is the number of cats, 30 is the number of dogs. That's why it's ratio of cats to dogs. 25 with the colon 30 expresses the same thing, and 25 divided by 30. Now if you notice, there's a common factor between 25 and 30, so each of these ratios can actually be expressed in a different way. I can write 5 to 6 instead of 25 to 30, so that's dividing both of those numbers by 5. And in the red case, I can have 5 colon 6. And in the green case, I can have 5 divided by 6. And that's precisely the ratio of cats to dogs. Now, if I want the ratio of dogs to cats, these are just flipped, and you write the number of dogs first. So for every 6 dogs, there are 5 cats. You can write it that way. And likewise with the others here, 6 to 5, and in green, 6 to 5. That would be the ratio of dogs to cats. Alright, let's do one more. So the moral of the story is that ratios are reducible in that sense. So part B, an employee earns 4 hours of vacation time for every 30 days of work. Well, we want the ratio of vacation time to time worked. Now when you're dealing in units as specific as time like this, you want to make sure that your units of vacation time are the same as the units of the days that you work. So I have hours and days here. So what I'm going to do is convert days to hours. Now, generally we have 8-hour work days. So I'm going to multiply 20 by 8. So 20 days of work is really 160 hours of work. All right, so we're going to convert that first. Now, if I want the ratio of the vacation time earned to the amount of time worked, I can express that as vacation time earned to the amount of time worked, which is 160. Okay? And I can also express that as 4 colon 160, vacation time to time worked, or also as 4 divided by 160. But again, you're going to notice that there's a common factor of 4. So this is really 1 to 40 if we divide both by 4, and I can express both of the other ones as well. The ratio of vacation time worked to time worked. Vacation time earned to time worked. And your final one here is 1 over 40. So what this ratio tells us in the end is that for every 40 hours that I work, the units are hours, I get 1 hour of vacation time. All right? So sticking with ratios, there's a second definition that's very important to us, and that's a unit rate. And the definition of a unit rate is that it's a ratio where the denominator is 1. Now these are very useful to us when we're comparing two different quantities. And so here's an example that I came up with. I love Twizzlers, so I went online and I did some searching to see what the best price for these Twizzlers can be. Now they obviously come in different size packages, 16 ounce, 24 ounce, and 32 ounce, and there's some bigger ones as well. And these are the prices I found: $1.99 for 16 ounces, $2.79 for 24 ounces, and $3.74 for 32 ounces. Now, I can definitely make ratios for these. So if I come on down here, I can make ratios for the price per ounce. And if I think about price per ounce, this would be $1.99, so let's do it in cents. So that's 199 cents per 16 ounces. That's a ratio. This is 279 cents per 24 ounces. and this is 374 cents per 32 ounces. Okay, but now as a buyer, when I look at these three things, I can't really tell what the best price is. But if I were to make this so that the denominator is 1 in each case, it'd be much easier for me to compare them, and that's what a unit rate is called. So I'm going to pause this and get these numbers for you. And so what I found is that the 16-ounce pack, for each ounce I'm paying 12.4 cents. For the 24-ounce pack, for each ounce I'm paying 11.63. Now I'm rounding these. And then for the 32-ounce I'm paying 11.69 cents per ounce. So clearly the winner here is the 16-ounce, the 24-ounce pack. So that's the best buy for what I found online here. Now I just want to point out that grocery stores actually do this for you. So here's an example I found for rice at a particular grocery store. And the whole pack of rice costs $2.40 here and $3.12 in this case. But they're different size packages, so you have 12 ounces and 24 ounces. So to determine the best buy, we can look at the ratio of cents per ounce that you're spending. And on the label in the grocery store, they actually do this for you. So we can see the unit price, again that's where the unit rate comes in, 13 cents per ounce there and 20 cents per ounce here. So clearly this guy on the left is the winner of the bigger package there. Okay, let's shift gears just a little bit and talk about proportions now. Now the definition of proportion is something that shows equality of two ratios. So for example, the proportion 4/5 is actually the same as the proportion 12/15. And you can see that just by multiplying the top and bottom by 3. This shows that the ratios 4/5 and 12/15 are actually equal. So the proportion, what we call the proportion, is this equality here, this equation. That's the proportion. It shows equality of two different ratios, and this is very useful for us when we're comparing ratios. So let's look down here at one important note about this. The cross products of a proportion will be equal. So if you take this proportion, 4/5 equals 12/15, and you cross multiply, so 4 times 15, and set that equal to 5 times 12. Those are the cross products. These two pieces here are called the cross products. And you'll see that they're both 60. So provided that we have a proportion, the cross products will always be equal. So before doing a few examples, let's just make one more note about proportions. Let's consider just an arbitrary proportion here, A over B equal to C over D. Well, if it's a proportion, then the cross products must be equal. So A times D must be equal to B times C. But if I take this equation now, and I divide both sides by C and then both sides by D, you'll see that I get a new proportion. This proportion actually contains all the same information as the original proportion, and you can always have that feature. So for example, if I say to you that 4/5 is 12/15, this is the same as saying that 4/12 is 5/15. So this proportion gives us this proportion for free, just by what I talked about above. Now, by the same token, you can also take this proportion and flip both sides. So take the reciprocal of both sides. And you'll maintain equality, and you can check that there. This proportion is true as well. And if I take this proportion on the right, and I take reciprocals, I can get a new proportion. So from one proportion, if I start with one proportion, I can find these three comparable proportions that are also always true. Okay, this is the end of part 1, guys. I'll see you in part 2.